All right, class, so yesterday we spent time learning how to figure out or find out the LCM, or the least common denominator, for a fraction. So today we're going to go back and figure out how to add and subtract fractions. All right, add and subtract fractions. So let's pull Santa out here. And here's what Santa says. If the addition rule for fractions, if you look here, did you notice my denominators are all the same? Because we know before we can add or subtract, we have to have a common denominator. So once we get our common denominator, we just do the math in the numerators, okay? We're going to have a plus b if we're adding, or a minus b if we're subtracting. Now, little reminder, how do we subtract in algebra? Yeah, that's right. To subtract in algebra, that means we add the opposite. So we may have to keep that in mind as we're going through and looking. Now, this is what it looks like algebraically as a math sentence. All right, so let's see what it looks like. Let's put Santa back. Let's see what it looks like if it's in words, and that's what my Christmas tree tells us. If we go here, then we know to add or subtract fractions with the same denominator. Okay, we add or subtract their numerators and write the result over the common denominator. Now, we may have to simplify the fraction when we're done, but I'll show you what I mean as we go. So let's look at number one. The first thing we need to check is, do I have a common denominator? And when I look there, I do. Both of my denominators are 15, so we're just going to do the math in the numerator. What's 7x minus 4x? Yeah, that's right. That is 3x. And then remember, we do the math in the numerator and we put it over our common denominator. Now, you've got to check it out. Can I simplify that fraction? Now, we're kind of back in section 6.1 where we learned how to simplify fractions, and this one's pretty easy. It's just a number thing. We know that 3/15 can be reduced to x over 5. Now, let's look at number 2. Do I have a common denominator? I do. So since I have a common denominator, we just do the math in the numerators, but did you see right here that I have a minus sign? We're subtracting. So since I'm subtracting, I've got to add the opposite. So I've got to take everything that comes after that minus sign and add the opposite. Well, I like to write it over again so I don't get mixed up on the signs. So that means 3a, and then we're going to add negative 5a. All right, negative 5a, and we're going to subtract 1. Now, if you remember from Math Pass, Mrs. Burton would write it this way. It's kind of like red flags waving, and we're going to change everybody's sign. So that positive 5a is going to become negative 5a, and that positive 1 is going to become negative 1, and that's all over my common denominator. Now, let's look at our numerator. Do you see what we need to do? Good job. We're going to combine like terms. So 3a minus 5a is negative 2a minus 1 over 10. When I look at that answer there, are we done? How do you know if you're done? Well, if I look at the numerator, do I have any more like terms to combine? No. Do I have a GCF? No. So therefore, I am finished with that problem. Okay, let's look at number 3. Once again, do I have a common denominator? Sure do. Now realize when we've got that common denominator, and you got to realize we're subtracting, so it's really important to realize what operation we're doing. Really look and pay attention. So that means I've got to add the opposite. So I'm going to go ahead and rewrite this. This is going to be x plus 3 and then minus 9x minus 11 all over 4. Again, because I'm subtracting, I have to add the opposite. And so now I'm going to just collect like terms. What's x and negative 9x? Well, that's going to give me negative 8x. And then we know 3 and negative 11 is negative 8 all over 4. Now, here's where we got to look. Look at that numerator. Is it simplified? Good job. We have a GCF. Now, I'm going to factor out a negative 8 since they're both negative, and we're going to have x plus 1 over 4. And now, did you realize that I can take these numbers out here and simplify? What's negative 8 divided by 4? 2, and then x plus 1. And that's my final answer. So we're still back at 6.1 after we take care of the adding or subtracting in the numerator to simplify that fraction. Number one, we got to see if there's anything we can factor. Honey-do list is still in play. Then hopefully something will cancel. All right. Now, let's look at number 4. Look at those denominators. Do we have a common denominator? Oh, they're not exactly the same. Do you recognize what they are? Santa does. Did you realize I have opposites in the denominator? Do you remember what opposites are? Yeah, that's right. We've got subtraction and the letters and numbers switched. How do I get rid, or how can I make opposites be the same? Yeah, remember Mrs. Burton's -1 thing? Okay, so if I use the -1 thing, now I've got n over n minus 2. And now we've got 3n minus 1 over n minus 2. But that -1 thing is going to also change that sign in the middle. So since it started as a plus, that means now it's minus. So, oops, look what Mrs. Burton did. This should be n minus 2. Sorry about that. All right, so now we're just going to subtract the numerators. Well, did you realize we're subtracting here? So I've got to add the opposite. All right, so that's going to give me n minus 3n plus 1 over n minus 2. And now, do you see what like terms I'm going to collect? Nice. N minus 3n is -2n plus 1 over n minus 2. So I really need to caution you to slow down. Realize if I'm subtracting, if we're subtracting like we are here, I've got to add the opposite. Don't forget to do that. All right. Now, let's look at number 5. Do I have a common denominator? Nice. Hey, we've got opposites again. So if these are opposites, if I recognize my denominators as opposites, we're going to have to do the -1 thing. So that's going to give me 5 over 4y minus 1. And then now this is going to be 3, 4y minus 1. But because I'm doing the opposites in the -1 thing, that minus sign is going to become a plus. Okay, so now let's just add the numerators. What's 5 plus 3? 8 over 4y minus 1. Good job. Okay, now let's look at number 6. When I look at number 6, do I have a common denominator? I sure do. So now we're just going to add the numerators. Now, what happens when I add this? If I have a squared plus 8 plus 6a, yes, good job. We're going to have a trinomial. So let's put it in the right form. That means I'm going to have a squared plus 6a plus 8. Remember, if I've got a trinomial, the right form is the quadratic term, the linear term is always in the middle, and the constant term is always on the end. Now, how am I going to simplify that fraction? Again, we're back to 6.1. How do we simplify the fraction? Oh, look at that numerator. Is there anything I can factor? Oh, well, I don't have a GCF. There's 3 terms. How do we factor 3 terms? Right, we're going to have to x factor. Okay, so we're going to get a and a. We know that both of our signs are going to be plus. What factors are we going to use of 8? 4 and 2. Good job. All over a plus 2. See why it was important to realize that we could factor those? Because now I have the exact same binomial, a plus 2, in the numerator and denominator. So when I cancel them out, my final answer is a plus 4. So after we get our common denominator and after we add or subtract the numerators, whatever the sign says, then we've got to simplify that fraction, which takes us back to 6-1 factor, and then hopefully something will cancel. All right, now, what happens though if I don't have a common denominator? What do you think? What are your thoughts? Can I say 2/7 plus 3/5 equals 5/12? Can I add the numerators and add the denominators and be done? You're right, I can't do that. We learned even back in grade school that to add or subtract fractions with unlike denominators, I have to rewrite them using the least common denominator. So instead of 5 plus 7 is 12, we know my common denominator, my least common multiple between 7 and 5 is 35. Okay, so these are my equivalent fractions, and now that I have a common denominator, I add the numerators, so we get 31 over 35. Now, how are we going to apply that to these algebraic fractions? Well, so let's look here at number 1. Now, this is actually what we learned yesterday. We learned yesterday how to come up with a common denominator. So if I look here at number 1, I definitely don't have a common denominator. So let's look. It's going to be a number thing and a letter thing. So if I have 3 and 6, what's my letter going to be? My number going to be with 3 and 6. Well, we know with 3 and 2, it's going to be 6. And then we look at our letters. Now remember, if our letters are common to both, we've got x and x squared. We take the higher exponent, so it's x squared, and then whoever's left over still comes to the party, so we need a y. So my LCD is going to be 6x squared y. Now, with that in mind, then, let's go ahead and make our equivalent fractions. Now, if you remember, Mrs. Burton likes to put her equivalent fractions right underneath so I can figure out what to multiply the numerator by. So, if I'm looking here, then, we've got the original, and here's my new one. So, how do I figure out what to multiply 4 by? Well, I multiply it by what's missing. So, I'm going to have to multiply 3 by 2. If you notice, I have an x here, but an x squared, so I'm missing an x, and the y's are both there. So that means my numerator here is going to be 2x times 4, which is 8x. What's going to happen on my second fraction? Well, we're going to have to take and multiply 2 by 3 to get 6. We've got the x squared, but we're missing the y. So now we've got 3y times 3, which gives me 9y. Now, got a question for you. What's 8x plus 9y? Yeah, it's 8x plus 9y. All over my common denominator. Again, when I look at that numerator, do I have a GCF? No. Do I have like terms I can put together? No. So I'm done. Final answer. Let's look at the next one here. If I have 15 and 10, what's my common denominator going to be? Well, if we have 15 and 10, we would choose 30. 30 would be my common denominator. So now let's make our equivalent fractions. So if I look at the first fraction here, I'm going to multiply the numerator by, well, 15 times 2 is 30. So I'm going to multiply the numerator by, this numerator by 2. In my second fraction, what do I need to multiply 10 by? Yeah, we need to multiply that by 3 to get 30. And so now, yesterday, that's where we left it. But today, we need to figure out what the answer is. So now, I've got to take care of my distributed property, and then we're going to collect like terms. So here we go. We've got 2a minus 12 plus, there's a plus sign in the middle, 12 minus 3a, all over 30. Okay, what are my like terms that I can put together? Did you realize that negative 12 and positive 12 cancel each other out? So we've got 2a minus 3a, which is negative a over 30. Okay, let's go ahead and look at number 3. What's my common denominator have to be? If we have 5, 4, and 10, what would our least common multiple be? Right, good job. It's going to be 20. So now I need to make 3 equivalent fractions. I'm going to have to multiply the numerator of the first one by 4. Again, because 4 times 5 gives me the 20, so that's going to give me 8m. Over here in the middle one, I'm going to have to multiply the numerator by 5. Okay, because 5 times 4 gives me the 20. And then in the last one, we're going to multiply by 2 to get my 20. All right, so now we've still got to go through and take care of our distributive properties so we can combine like terms. Now, did you realize that was a negative sign right there? So that means red flag's waving. So let's see what we've got. If I'm looking at my numerators, here's what we've got. We've got 8m, and now I've got negative 5 times m is negative 5m. Negative 5 times 4, we did this, and now we're here, is going to give me negative 20. We got a plus sign, so we don't have to worry about that. 2 times 2 is 4 minus 2m. So that's what's in my numerator, and all that's over 20. What like terms can we put together? Yeah, we've got 8m minus 5m, which is 3m, minus 2m gives me m. And then we've got negative 16 and positive, I did the answer, negative 20 and positive 4, which is negative 16, all over 20. Am I done? Yeah, I can't reduce that. Okay, don't have a GCF, I can't factor, and so all done. Now, let's look at number 4. When I look at number 4, we need to come up with a common denominator. Now, when I look there, my first question, is there anything common to both? Now, I know they both have y's, but the answer to that question is no. And the reason the answer to that question is no is because this y is attached to, it's a binomial, it's y minus 6. And this y is a monomial. So there's really nothing common to both. And so this happens a lot. That means if there's nothing common to both, then everybody comes to the party, and that right there is my common denominator. All right? So y minus 6, the y in the binomial is not the same as the y that stands alone, so they both come together to the party to be the common denominator. So now, let's make our equivalent fractions. Between here and here, what are we going to multiply 3 by? Well, we've got the y minus 6, so we're going to multiply by y. And then in the second fraction, I've got the y, but I'm missing the y minus 6, so it's going to be 1 times y minus 6. Now, did you realize we're subtracting? So if I take care of my numerators, we've got 3y minus y plus 6. Everybody realize I had to add the opposite here because we were subtracting? All over y times y minus 6. Look at your numerator. Is there anything else I can do? Yeah, we got to combine like terms. 3y minus y is 2y plus 6 over y times y minus 6. Is that in simplest form? Did you see I have a GCF up here in my numerator? So I've got to factor out the GCF. We're going to factor out a 2. And we have y plus 3 all over y times y minus 6. And that's my final answer. If you remember, as we've gone through and done all these problems, my answer has to be in most factored form. Okay, let's go ahead and try this one. Now remember, before I can find my least common multiple, and I look at those denominators, I might have to factor. So if I look at this first denominator here, that's difference of perfect squares. So I know that has to be y plus 5, y minus 5. Okay, so now let's come up with our common denominator. Well, did you notice y minus 5 is common to both? So it comes down, and then everybody else comes to the party. So that means my common denominator is y minus 5, y plus 5. All right, so now when I compare my fractions, the first fraction actually has the right common denominator. So I don't have to make an equivalent fraction. It's right. But when I look at the second fraction, I have the y minus 5s, but I'm missing the y plus 5. So now I've got y times y minus 5. Okay, let's take care of our numerators. What's going to happen? We've got 2y minus, well, y times y is y squared, and a negative times a negative is a positive 5y all over y minus 5, y plus 5. Now that looks kind of weird to me, okay? And did you realize that we have, we need to combine like terms? So we've got 2y plus 5y is going to be 7y. So we've got negative y squared, and then we've got plus 7y all over y plus 5, y minus 5. And hopefully you realize we have a GCF now. All right? So we're going to have to factor out a y, and we're going to get y. Let's factor out a and then we're going to have negative y minus 7 all over y plus 5, y minus 5. Okay, it gets a little bit hairy when we've got those binomials in there. Okay, let's try number 6. Here we go. Again, when I look at those denominators, I'm going to have to factor those before I can come up with a GCF. So the first one has an n squared, and we're left with n minus 5. And when I look at the second one, well, I have a GCF again. This time it's an n, and we're left with n plus 5. So let's look. If I'm coming up to find my common denominator, okay, what's common to both? Well, I've got n squared and n, so remember we always take the higher exponent, and then my n plus 5 and n minus 5 come to the party. N squared, and then we've got n plus 5, n minus 5. Okay, everybody understand my common denominator? Again, I said a lot of times everything just files down. So we've got 2n times, what are we missing between the top one, my original, and the bottom? Well, we both have n squareds, and we have n minus 5, so this is going to be n plus 5. And if I go to the second one, between my original and my new common denominator, I've got a 2, and then we're going to multiply by the n, because we have n squared, so we're missing an n, and then n minus 5. So let's take care of the distributive property in our numerator. We've got 2n squared plus 10n. There's a plus sign in the middle. And now I've got 2n squared minus 10 all over my common denominator. And we've got n plus 5, n minus 5. Now, let's combine like terms. Well, did you notice we've got 2n squared and 2n squared, which is 4n squared, and we got positive 10n and negative 10n, so they cancel out all over my n squared, n plus 5, n minus 5, and hopefully, did you notice I have n squareds on the top and the bottom? So final answer is 4 over n minus 5, n plus 5. All right, class. Hopefully those examples will help you tonight on your homework, and we will pick up here tomorrow.